Hello everyone, I am Kumar. I am a lecturer of Electronics Department. In this video, I am going to discuss about semiconductor materials. Here is my content page. We will understand the learning objectives, then we will discuss about electronics, classification of materials as conductors, insulators and semiconductors. We'll understand energy band and energy band diagram, how the bondings is there in a semiconductor material. We'll also understand intrinsic and extrinsic semiconductors and semiconductor properties, followed by assignments and references. After completion of this module, you will be able to define electronics. You can classify materials as per the electrical properties. You can illustrate energy band diagram. You can also define intrinsic and extrinsic semiconductors. So, what is electronics? We can split the word electronics as electron and mechanics. So now the definition is clear. Electronics is a subject or a field of science or engineering that deals with the motion and behavior of electrons. As per the electrical properties, that is either conductivity or resistivity, we can classify materials in conductors, insulators and semiconductors. Conductors have very high electrical conductivity and very low resistivity. For example, copper, it has a resistivity of 1.68 into 10 to the power minus 8 ohm meter. Aluminium is also a conductor. Insulators have very low electrical conductivity and very high resistivity. For example, mica has a resistivity of 10 to the power 13 ohm meter. Wood is also an example of an insulator. Semiconductors have electrical conductivity or resistivity in between conductors and insulators. Silicon, germanium are common examples of semiconductor materials. Silicon has a resistivity of 6.4 into 10 square ohm meter and germanium has a resistivity of 4.6 into 10 to the power minus 1 ohm meter. So it is in between conductors and insulators. So now what is energy band? Basically, energy band refers the energies of an electron. So how much energy an electron can have, that is known as the energy band. As we know, the outermost orbital electrons take part in bonding. They are known as valence band. The outermost orbital electrons, when excited, they can jump from valence band to conduction band. Now they can freely move in the material, which causes the current flow. If we observe the energy band diagram of an insulator, we'll find that it requires more than 6 electron volt energy for an electron to come to the conduction band from a valence band. In case of semiconductors, it is around 1 electron volt. For the conductors, it doesn't require any energy. Electrons doesn't need to have any extra energy to come to conduction band from the valence band, as these two bands are overlapped. So as per the energy band diagram, we can also define semiconductor as the material having a band gap of around 1 electron volt. Bondings in semiconductor. We know silicon, germaniums are semiconductors. As we can see, they are group 14 elements, or we can say their valency is 4. Valency 4 means they make 4 covalent bonds with neighboring 4 atoms. Now with increase in temperature, some of these electrons, they can break the bond and they become free electrons. Now these free electrons are responsible for the conduction in the material, and the material is known as the intrinsic semiconductor. In normal temperature, a very few electrons, they can break the bond and they become free. As the number of electrons is very few, that is why the conductivity of intrinsic semiconductors is very less. To improve the conductivity, we can add other materials in pure semiconductor. For example, we can add phosphorus. Phosphorus is having 5 outermost orbital electrons. Out of these 4 electrons, they make covalent bonds with neighboring silicon atoms, and one electron is always free. Similarly, if we add a trivalent material like boron, so boron has 3 outermost orbital electrons, so there will be a hole created. The holes are positive in nature because they are absence of electrons. Electrons, they have a negative polarity, and the absence of electrons, that will always attract negative polarity, and that is why the holes are positive in nature. So now we can define semiconductors as materials that have conductivity in between conductors and insulators. With increase in temperature, they will show less resistance, and if we add other impurity to the material, then the conductivity will increase. So this is the assignment. For more information, you can always refer to this book, Electronics Fundamentals and Applications, written by D. Chattopadhyay and P. Shirakshit. This is all for this lecture. Thank you.